Okay, welcome to combining functions graphically. Um, so we're starting a new unit today, and once we're done this unit, we'll actually be halfway done the course. We are basically going to begin examining how we can actually add, subtract, multiply, or divide functions, and to get other functions. Um, Today is pretty much we're just gonna start looking at them graphically. We're gonna kind of examine exactly what's going to happen when we start doing these operations. So we can write that down for goals for today. Sorry about the cap lock. It's just the way I roll. How do you spell behavior? Let's go with that. There we go. So yeah, this is what we're doing today. What happens when we add, subtract, divide, or multiply functions, and how can we predict their behavior? So we're going to start just by, we're going to use these two functions for all four operations. So we're actually going to start with addition. So we got a linear function and we got another linear function. And let's look at what happens when we add them together. As far as notation goes, so for notation, we might write this, but this is most likely what you're going to see. You're going to see f plus g of x. So that's how you say it out loud. In your notes, I have it all done on a graphing calculator. I'm going to say you don't really need to worry about it, but if you want to follow along, you definitely can do it on your graphing calculator. So you just go to the plot. So there's a button that says plot. And when you access that button, you should see something like this. You can clear anything that's in there, and you can type those functions in, and then you can type in y1 plus y2 to add them together. I'm going to show you guys on Desmos. Oh, ruined the surprise. Whoops, that's kind of awkward image history. Okay, so right here, the red line, that is negative 2x plus 6, so it's a line. It's kind of what we're expecting. The blue line, we're calling it g of x, and there's x plus 1. So when we add them together, I'm going to activate that one down here. So here we go. So now this green line is actually showing what happens when we add the two functions together. Um, and if you start looking at the the y values are going to be key here. It actually looks like, to me, that we're actually adding the y values from the red function and the blue function. So if we check it out, if we look right here, for example, just going to zoom in a bit, right here, um, on the green function, we got the point -1 for x and 8 for y. So if you look at the red function, we got 8 for y, and if you look at the blue function at -1, it's at 0. So 0 plus 8 is 8, and that is the green function. If you look at the y-intercept here of f plus g of x, it's 7. And that makes sense, because on the red function, the value for y is 6, and on the blue function, it's 1. 6 plus 1 is 7. So all that happens when you add these things together is that the y values add up. So here it is on the graphing calculator. I have everything labeled here. So important thing to notice is that our new function is literally just the sum of the y's in the first one and the y's in the second one. As far as domain, in this case, our domain doesn't change. So it's still all real values. Um, and that's because f of x and g of x have that domain. That's not always the case, but for addition, that's what's happening. Okay, let's do subtraction now. So if you're doing it on your graphing calculator, what you can do is change y3 to y1 minus y2, just like that. Um, If you're not doing it on your graphing calculator, no problem. I got it over here on Desmos. So once again, we got the same two functions. So negative 2x plus 6, x plus 1. Okay, and prediction would be when we subtract them, I'm going to expect that the y values for each function will actually subtract. We'll get a new function. So there's the green line. Okay, the green line represents f subtract g of x. So let's just take a look at, say, our y-intercept here. So y-intercept on the new function is 5. If you look at f of x, the y-intercept was 6. On g of x, the y-intercept was 1. 6 subtract 1 gives us 5. So it is important that you notice that the order of the subtraction is the y value on f subtract the y value on g. So the order does matter. Let's see if that holds up for some other points. Just trying to pick an easy one. So let's pick this one. 1 for x and 2 for y on the new function. If you look, this might not have been that good of an idea. Oh no, we're fine. So on f of x, our y value, trying to get it here, you can see that it's 4. Okay, so 4 subtract, and if you look on the blue line, the y value is 2. So 4 subtract 2 gives us 2, and you can see it here on the green line right there. That's the y value. So once again, we come to that conclusion that for subtraction, okay, so f subtract g of x, all that's happening is the y values are subtracting. So if you want to write that in your notes, sorry, I got caps locked on. That's pretty much it. So we're just taking the y values on f of x and we're subtracting the y values on g of x. We can do a little recap. So for addition, we add y values of each function to obtain the new function. For subtraction, well, I'm going to say see above. Okay, so if you flip the page in the notes, again, I have that subtraction on your graphing calculator. It's just so ugly compared to Desmos. Moving along, if we change it to multiplication, it starts getting a little bit trickier. And before I show it to you on Desmos, I just want to kind of add a page here and just let's write out f of x. So I think that one was negative 2x plus 6. And let's write out g of x. I think that one was x plus 1. Okay, so we want to know what happens when we compute f times g of x. Make a prediction here. So my prediction would be, well, we're just going to multiply the y values for f of x times the y values for g of x. So if we actually plug in our functions here, so there's f of x, g of x is x plus 1. Now, if you FOIL this out, I wonder what we're going to get. Let's see. So we're going to get negative 2x squared, and then we're going to get negative 2x plus 6, so we're going to get plus 4x plus 6. What is this? So something that has highest degree as a squared. Anyone? Anyone? You pay. Don't stress out. This is a parabola. So that would be my prediction. That's smiley faces for you, you pay. So let's take a look at Desmos. And here I have it on the next screen. So I got negative 2x plus 6. I got x plus 1 right here. Boom, bada boom. There it is. F of x times g of x is the green parabola. Okay, and as expected, it's opening down because of the negative, and it's a parabola. Let's just take a look at some of these y values here. So if you say, look at the root on the green one. So if you look at the y value for our red function, it is at the position x equal 1. Looks like our y value is 8. If you look at the y value on the blue line on g of x, well, it's 0. 0 times 8 is 0. Okay, so that's why on the green function we have a 0 there. On the other side, similar logic. Okay, so the red function here, it's crossing the x-axis. So that's going to be one of the zeros on the parabola. If we just trying to find another good point to look at, let's look at the y-intercept. Okay, so on the red function, the y value is 6. Okay, on the blue function, we got a y value of 1. Well, 1 times 6 is 6. So there's our y-intercept. And again, we're just doing these graphically today. So doing what we did here is actually kind of a step beyond. When we start doing them algebraically to find the vertex and all that stuff, you would probably be expected to multiply it out just like this. So we're just getting a little ahead of ourselves. All right, so that's multiplication. So if you can add just one page to your notes here, and let's just kind of recap multiplication. Okay, so basically we are multiplying the y values. So we multiply the y values of each function. Okay, so in this case, for two lines, we got a parabola. That makes sense when we look at the equations. It's not necessarily always like that, but in grade 12, we really don't go any further. It can get really complicated really fast. So the important thing to know is that if you're multiplying functions, again, it's the y values that are getting multiplied. If we start looking at domain and range, so for domain and range, it's just important to note that f of x and g of x are lines, so they don't have any restrictions on the domain. And in the new function, the one where we multiply them together, again, we have no restrictions on the domain. That's possible because the original functions don't have any restrictions. There is a restriction on the range because it's a parabola and it's opening down. You'd have to figure out your vertex point. So maybe just looking a little ahead, but if you know the equation of your parabola, you could say find your x-intercepts. So I'm just going to pull out a -2 here. I said I was going to pull out a -2, but then I didn't. Let me try again. So if I pull out the -2, I'm just going to do this all again. Uh-oh. There we go. So I'm going to get x squared. I'm going to get -2x. I'm going to get subtract 3. And I should really have this equal to 0. Okay, if you don't do that on the exam, you're gonna kind of lose like half a mark there. Okay, so when I factor this, two numbers that multiply to -3 but add up to -2 are going to be -3 and +1. Okay, so we can find our x-intercepts easily enough. So setting y equal to 0, we're going to get x equal 3, and we're going to get -1. Remember from grade 11, to find your vertex, if you know your x-intercepts, you can just add them up and then divide by 2. So if you go 3 plus -1 and divide by 2, you should find the x-coordinate of your vertex, which is going to be 1, and then you can plug that into the original function to get your y value. So if you plug 1 back into, say, here, so if you want to find your vertex, we know x equals 1. We'll just put y value of the vertex. So if you plug in 1, I'm just going to do some quick math here. I'm going to get 1 subtract 3, so I get -2 1 plus 1 is 2, so I'm going to get 2 times 2 times 2, which is 8, and it's positive 8 because of the two negatives. So your vertex is going to be 1, comma 8. If we go back and look, we can see that's true on our graph. So for the range, we know it's opening down, so we can figure out the restriction on our range. So again, today is not necessarily about doing this stuff algebraically. We're doing it graphically on a graph, but this is where we're going in future lessons. Okay, last one, the final operation is division. Division gets really hard really fast. Okay, so generally on the exam, you don't really tend to see division. I can't think in recent years. I don't think there's been a division one. They stick to addition, subtraction, and sometimes multiplication of functions. We still have to look at it because technically it could show up. So once again, we're using those same two functions as before, and the graphing calculator is just garbage. This is hard to see what's going on. Here's y1 and y2, so you can see those linear functions. And I'm just going to make it worse here. We should just switch over to Desmos. Let's do that. So here is f of x, negative 2x plus 6 and x plus 1. Let's look at what happens when we divide the functions. Of course, we could predict we're going to get probably some kind of an asymptote. With g of x in the denominator, you're going to get x equal negative 1. That's definitely going to be an asymptote. So now we're back. And you can see the green line, so you can see the L shapes. And Desmos doesn't really show the asymptote. I can graph it here for us. I can go x equals negative 1. So you can see that asymptote there. It's the orange line. So you can see the L shape going and hugging the asymptote, and over here. Okay, so that seems to make sense, that if we divide them, chances are we're going to get an asymptote. And if we start talking about domain and range, it can get really hard really fast. Probably your best bet would be to look at it algebraically. So if we switch back to our notes, can just read this out. We just notice that for various x values, your y values are going to be the y value of your first function divided by the y value of your second. So that explains our vertical asymptote. If I write f of x over g of x, okay, because it's a fraction, we know that we got a non-permissible value here. X cannot equal negative 1. That's giving us our asymptote. The domain is tricky to figure out. Okay, so this is why the exam tends to stay away from doing the division questions. So even though the original functions have a domain of all real numbers, right, because they're lines, on the graph of f of x divided by g of x, that's not the case because of the division. So the domain has a restriction. Okay, so by the non-permissible value x equal negative 1, that's the restriction there. The range, again, can be tricky to figure out, so you have to have intimate knowledge of the graph or draw it. So the range in this case, you can see there's going to be a horizontal asymptote as well. So again, if we go back to our original graph, because the degree is the same for both, we're expecting a horizontal asymptote at, and I'm just waiting here, giving you time to think. We do the leading coefficient in the numerator divided by the leading coefficient in the denominator. So we're expecting a horizontal asymptote at negative 2. You can see that on Desmos, those green lines are not crossing negative 2. So you can see it going and hugging. I can plot that point there. So you can see that they do not cross that purple line. All right, so this big mess, this is the reason why the exam tends to stay away from those functions. Okay, if you could just flip your booklet over to the next page, we're going to try a practice problem. So really, we can kind of throw anything at you. So this one here, we got two graphs. We got the square root of x plus 2, which is this one right here, which I will highlight in red. Doing my best. So that's f of x. And then we got a nice line, negative 2x plus 4, which I will just leave it in black because that looks hard to highlight. Okay, so um, let's see, what are we doing with this? Let's sketch a graph of f of x times g of x. So remember, we multiply the y values. We multiply y values. Okay, and to get a sketch, you just need to pick a couple smart points. So I'll do the sketch in green. Any intercepts, of course, is something that you're going to want to look at. So here, starting on the left-hand side, we have an x-intercept here. Okay, so we're multiplying the y values. So the y value here on the square root function, that's 0. Okay, so it doesn't really matter what the y value is on the line. It's 8. 0 times 8 is 0. So that's the starting point of our graph there. So I'm going to erase this dot up here. All right. And then you just kind of want to pick points that are easy to identify and multiply together. So you may, example, want to use this point and this point. Okay, so at x equal negative 1, we got y equal 1 on the red function. And on the line, this is going up. So this is 6. So 1 times 6 is 6. So this point right there, and I'm just going to erase this one down here. This point right here at 6 is going to be on the resulting graph f of x times g of x. Probably another point that we could use the y-intercept. It'd be nice, but it's a little hard to understand what's going on in the red function. Looks like it could be 1.5, but not sure. So we're just going to go over here to this 0, and I'm going to highlight it in blue this time. Okay, so the y value here is going to be 0. On the other function, it doesn't really matter what the y value is because 0 times anything is 0. So we know that our resulting function is going to be right there at the green dot. Okay, this should be enough information for us to sketch our graph. So if you start on the left-hand side, we know that this thing is going to start here and just connect the dots, use a smooth curve. It's going to go here. We can approximate 4 times 1.5. That's going to be roughly, and this isn't quite 1.5, but 4 times 1.5 would be 6. We're not quite there, so we know we're just going to be a little bit lower. Okay, so we know the graph is going to come down, and then it's going to want to go through that point, and then we can just draw it continuing on. That's all you require for a sketch. Okay, so in the notes, there's a couple tidbits of information. Notice how, the roots are obvious points that you want to use. Y-intercept obviously is going to be another one. Hopefully it's a little bit easier, but it's really not that bad. Talking about domain and range, that's usually a question that they ask. So domain and range of the resulting function isn't so bad if you have the sketch. Okay, so you can see that the domain gets restricted. The line has domain of x element of the reals, but on the resulting function, because of the square root graph, the domain gets restricted and it's negative 2 to infinity. Okay, you could also write that as x greater than or equal to negative 2. The range goes up. The highest point that we get is 6, and then it goes down to negative infinity. So range, highest point that we're going to get is 6, and then we go down, so we can say y is less than or equal to 6. I think that's pretty much it. At this point, I think you got enough information. There's a practice one that you can try. I think, well, we don't have the textbook anymore, so at this point you can really just go and work on your note package. There is a supplementary sheet that you can do, and before we leave, I'm just going to back up a step and let's look at some conclusions. Okay, so the domain of a function will be the same as the domain of the most restricted function for adding, subtracting, and multiplication. Notice how we don't have division there. Division is a lot harder to tell. Okay, so if you're looking at domain, it's going to be the most restricted domain of whichever two functions you're adding, subtracting, or multiplying. Um, Number two, the range. Range is always tricky. Okay, so it's difficult to determine, and if it's requested, it might be a calculator question, but really in future sections we're going to learn how to do this algebraically. So you probably just want to look at the equation. Look at the equation or the graph, because you'll get questions where they give you the graph, like the one we did together, or questions where they just give you the equation and say, what's the domain or what's the range. Um, Conclusion number three, the domain of, sorry for the typo, so the domain of the operation uh, is division is complicated by non-permissible values in the denominator. Um, so yeah, if it's division, so if we're doing a division question, the domain can get complicated by whatever's in the denominator. So if you think back to the question that we did that had division, where did it go? This one here. So our domain got restricted by that non-permissible value, and the range even more complicated. All right, so you don't really need to do this last part. Okay, so hopefully that was useful for you guys. Sorry that I couldn't be here today. And I think you guys can just work on this. Congratulations, you did it.